Okay, in this example, you notice that we are subtracting the logs. So we're going to use the quotient rule of logarithms in order to solve this problem. And we'll also need the power rule as well, because we can't really use the quotient rule with that 2 out there in front of the log. So I'm going to use the power rule first, and then the quotient rule second. So let's rewrite the expression using the power rule first. Okay, so first of all, I need to do some student rule. Yeah, that's better. Okay, so all right. So instead of writing 2 log base 3 of x, I'm going to write log. I'll put the 3 in there later. X squared. I took the 2, which was in front of the log, and wrote it as an exponent. All right, and then I'm just going to rewrite the rest as normal. Okay, remember these are all base 3. So we've used the power rule. Now we can go ahead and use the quotient rule, because the log base 3 of x squared minus the log base 3 of 4 is simply going to be the log base 3 of x squared divided by 4. Log x squared, and I'm going to put that 3 in there also. And of course, this is also equal to the log base 3 of 25. Okay, so of course I do need my base 3, so I'm going to copy them and add them. See, 3. And do I have another one? I can put 3. All right, I just realized I don't have to text those things. I can just leave them like they are. All right, so that's where we are right now. Okay, now notice I got log of base 3 on both sides. That means I can drop them, and then I'll just be left with the arguments. I know I threw my 3 around when I did that. Yeah, that's what I want. Equals to 25. All right, so that statement, I moved it out the way. There. Okay. All right. And again, the bases were the same. So what do I do now? Well, I multiply both sides by 4 so that I can get the x squared by itself. So that's going to give me x squared equals 100, because I multiply both sides by 4. And of course, there are 2 numbers that I can take. If I take the square root of both sides, then that means x can either be a -10 or it could be a +10. All right, it could be that. Or could it? Well, let's see. If we let x be equal to -10, it looks okay here, but here's where we run into a problem. 2 log base 3 of -10, that doesn't exist. So we're going to have to throw out the -10 and just keep the +10, which I'm going to erase right here. Of course, if we could also look at this, if we looked at this graphically, matter of fact, if you look at the graph of the problem, you'll see that there is only one intersection. So there is no intersection at -10 because it's not even possible. The log function doesn't even is not even defined at x is equal to -10.